Hi, everyone. I'm Amit, Plexistor CTO. I'm going to take you through some numbers. You've seen a bit in Sharon's presentation. So first of all, what I'm not going to show, right? So I'm not going to show you the installation. It takes a few minutes. You can do that by yourself. I don't enjoy looking at CLI commands on a black screen. I'm not going to take you through the GUI and show you that it's nice and smooth. Actually, it can be improved still. I am going to take you through the efficiency and the performance aspects of the system, and some of that, obviously, not everything. And specifically, there are 4 different benchmarks, actually 6 benchmarks, but 3 of them use FIO. So most of them use the POSIX API, the read and write semantics. And Cassandra is actually using MAP, so memory semantics as well as writes. I mean, it uses both. And the system is, well, we'll talk about that. OK. So these are the 6 benchmarks. I hope you can see that from where you see it. Basically, we compare ZFS, XFS, and Plexistor head-to-head on throughput. And at the same time, something that's not really usual when you see specific latency as well, right? So a lot of times you see the specification describes either maximal throughput or minimal latency, but it doesn't describe both in the same benchmark.
I'm a little confused.
Go ahead.
So to me, ZFS and XFS are a file system.
Right.
You're a file system, but you're a file system that's storing stuff in very different ways. So ZFS could be on top of a RAM disk. ZFS could be on top of a flash disk.
Right.
So this ZFS, how? ZFS where?
So in this configuration, it's a persistent configuration. So it's a ZFS on top of cloud speed SSD. XFS the same. In our case, it's a hybrid of NVDIMMs and SSDs. And you're right that data locality plays a large role in this, right? So the first 3 benchmarks are basically 100% in memory, right? In NVDIMMs in this case. And the last are basically, those 2, MongoDB and Cassandra, are large working sets which use both SSD and the NVDIMMs together.
So, unless I don't understand something, when I'm installing up in AWS, I don't have NVDIMMs.
Right, exactly.
So how is that?
So when you're running,
what are you doing differently than they would be doing if you don't have
NVDIMMs? So basically, I think Sharon touched on it, but didn't really explain that. We have 2 different configurations, right? One would be an ephemeral configuration, which basically the Amazon one is an ephemeral configuration. In that configuration, we basically use DRAM resources if it was NVDIMM, right? So we use that as the first tier. Obviously, that is not persistent by definition. The EC2 instance in Amazon is not persistent either. I mean, it has an SSD. You can't really reach that SSD if there's some crisis anyway. So on that level, I mean, the DRAM on Amazon is as or actually in private clouds as well, is as persistent, which means it's not as the SSD itself, right? I mean,
well, so you are comparing an ephemeral instance with ZFS, which is persistent.
So these are just a taste of performance, right? I mean, we can do other setups. It's going to act the same way, right? I mean, if you're doing a synchronous write on an ephemeral configuration and on a persistent configuration, the hardware choice is different, but the performance is going to be the same.
But the problem that works on premises and on the cloud, right? So if I have ZFS at home, I'm writing on ZFS,
right,
and I lose power.
Yeah.
I have all my data. So I suppose when you test your configuration, you have a similar setup. So if I lose power in your physical machine with Linux, I will have my data back.
Okay, so let's do this
And then,
in an
then
orderly
compare
fashion way.
performance.
Okay, let's start with the persistent. That's easier to grasp, right?
And
if you're using NVDIM in the persistent configuration,
could you maybe draw it as well? Because I'm kind of having
like,
trouble.
Give us a day in the life of an I/O in Plexistore.
Apparently, it's two very different lives. There's the cloud life.
right?
And the,
At the moment, there are two different options, right? There's a mount option for the file system. You either choose ephemeral or you choose persistent. Okay. If you have NVDIMs, you basically choose persistent, right? Everything is persistent, just as XFS and ZFS.
Right.
If you're using the ephemeral flag, then basically you can use it for several different things. It's not good for everything. Okay. We will persist the data on an orderly shutdown system. I mean, we basically use the second tier to store all the data. But if there's a power loss or something like that, you need to compensate for that in another mean, right? So either the application doesn't care. I mean, it's a share-nothing application, just like Memory 1, which I believe was presented here from Diablo, right? It's basically using DRAM. It's willing to lose some of the data. It's willing to lose an entire node. The application knows how to recover from that. Okay, so for that use case, it's fine. Another use case would be, scratch space, test and dev, stuff like that you can basically rerun as well.
Yeah.
A third use case could be maybe you do want persistency, but instead of going on and buying the server with the NVDIMs, which is not trivial today, you just want to see the system provides the value before you go ahead and purchase NVDIMs.
Is there any way to kind of flush or destage that ephemeral data at all, even if it's in the form of similar to a snapshot or that kind of thing, so that I could, for example, achieve an RPO of an hour or half an hour or something and just do a dump of my data on a regular basis?
Yeah, so currently, I mean, let's start with the simple stuff, right? Once you mount the system, basically everything is going to be stored to the second SSD-based storage, right? That also allows you to move from Haswell, for example, to Skylake, and to move from NVDIM to 3D Crosspoint if you want something like that. You just move the disk with it and you remount it. Or change the number of NVDIMs or anything like that, right? So it provides you an ability to move from between platforms as well with the data. If you're looking for something lighter, let's say, right? That's also possible. That's not in the current release that's publicly available. But basically, you just take a snapshot, or you use one of the ioctls that basically asks the system to flush down. Well, it's not really flush, but copy all the stuff, so it's also on the second tier as well.
So I was thinking more of in the ephemeral model as well. So
I'm talking about the ephemeral model.
yeah, but you talked about unmounting the disk. Like we're not going to unmount this.
That was the first use case.
Okay.
I mean, there are several scenarios. The U-mount was for the first scenario where you actually want to move to another platform, okay, or you just want to turn off the machine or something like that.
Mostly we're storage guys and we're paranoid.
Yeah. But I mean, also we have the ioctl that you can use without you mounting the machine, and also you can use snapshots for that as well in you mount something like that.
But
not in this version though.
I saw HDFS in one of the first slides. Mm-hmm. This is not a distributed file system.
So HDFS is actually looks like an application from my point of view. I mean, it's someone that uses POSIX, and I'm talking about the layer below POSIX.
Right, but Plexistor is a local file system, right?
It will always look like a local file system.
No,
yeah.
I'm not asking about how it's presented. Mm-hmm. I've got 50 servers running Plexistor.
Okay.
That's 50 pools of data, not 50 pools of storage, not one pool of storage, right?
At the moment, yes.
Okay.
Okay.
Just.
I'm not going to disclose the entire roadmap, but
no,
at the moment, the answer is at the moment.
And we're not worried about roadmap yet, but you had a diagram that shows multiple servers, like everybody who does a distributed file system that makes one pool of it does, and we need to know, were you implying that or not?
Yeah, we're just trying to figure out what road we're standing on.
Single node configuration, absolutely.
Okay.
That's what's available now in the market.
So, what I want to see on this slide is Plexistore performance versus Linux with FlashSoft, or some other solution that's going to use the RAM as a cache, because you're very specifically saying the RAM isn't a cache. And look, when I auto tier between RAM and SSD, I'm 15 times faster than if I just use the SSD. Well, I would kind of assume that. What I'd really like, but what you're competing against is, well, if I use the RAM as a cache, how far do I go?
So we actually tested this. It wasn't on the recent kernel versions, but I think that was like 8 months ago. And using one of the earlier versions of PMEM as the PMEM drive in Linux. So it actually was 100% RAM for XFS. I don't think we've done that for ZFS, but for XFS at least. And it was slower than using an SSD. And the reason for that is basically because you have a DMA engine in the the SSD and move stuff
Allow
faster.
me to say, the reason is because it's not a very good RAM disk.
That was what was available, 8 months ago. Maybe it's better now. I'm not sure, but we haven't run the test.
So,
but anyway, what it's so the idea here is not to bash ZFS or XFS. Okay, the notion here was to show you what's available today, what people are using today versus what they can have, right? So obviously you can do a lot of other performance benchmarks as well. Those 6 that do not represent the entire spectrum of the possibilities.
okay. And I assume that if there's a power failure, that when Plexistor comes up, it reads the NVDIM and brings up,
Yeah, reads the NVDIMs, the
Right,
second tier as well.
It sends
all the super blocks.
unflush from the flash back to the RAM, and
Yeah, it rebuilds everything and
okay.
does also an online FSCK at that occasion as well.
Now, I want to make sure that you understand the ephemeral setup, and I know it sounds unfair benchmark. You're saying cache is read, we're doing writes actually. The benchmarks are for writes, not for reads.
Right, well, but could be a write-back cache.
Yeah, absolutely. But I think we need to understand that the ephemeral setup is for a very specific use case. When you're running in Amazon, by definition, the machine by itself is ephemeral. So
Right,
there is no point in providing persistency.
If an AWS compute instance crashes, the data on its SSDs is lost because it comes back on a different host.
Exactly.
Right.
If you didn't push it down to EBS,
Right.
you've got
And
nothing.
So there's S3, there's EBS, and there's ephemeral.
Right.
Yeah.
Right. So, and this is really machines like Cassandra that runs on an EC2 machine that by definition is ephemeral, and Cassandra is responsible for the replication set.
Yeah, it's looking like a great platform for the kind of applications HPC guys run that periodically checkpoint.
Right. And that's exactly what MongoDB is doing.
So the application is responsible
My
for...
problem is different here. So your solution looks great on paper, okay? No, I didn't understand actually, but theoretically.
I'm getting it.
The problem is, okay, even if I trust you, you are comparing Cassandra to AWS. But then I buy Cassandra from AWS, I won't build on AWS a Cassandra cluster. Right. So for me, it's much easier to buy Cassandra from AWS and not build my own Cassandra cluster on AWS, right? So I would like to try, for example, Cassandra on, let me say, DigitalOcean.
For example.
Okay? And compared to your solution on DigitalOcean. So I have something, because DigitalOcean doesn't have a Cassandra service.
Right.
Okay, as well as any other big data kind of service. Because probably Cassandra, as it is in Amazon AWS, I don't remember the name of the service, it's Dynamo or whatever. I don't want to, okay. It's not that a problem. So the problem is, so potentially that Cassandra is much more optimized than everything I can get on a single instance.
So you're absolutely right. I mean, if Amazon is providing Cassandra service, again, I'm not aware of that, but let's say that they are, that's absolutely fine. We actually done the same benchmark, not just on AWS, we also did it on...
This one is on-prem, this Cassandra
This Cassandra
example.
is on-prem, but we've done the same thing, the same benchmark for other cloud providers like SoftLayer. And we're seeing, again, the same experience. Once a machine going down, it's by definition ephemeral. It's the responsibility of Cassandra to maintain its own replication set. So if you're running on-premise, if you're running soft layer or any other data center or data cloud provider do not provide his own Cassandra services, we can show you, we can provide you the benefit. Okay?
So I'd like to get to the technical stuff. Anyway, so just going through this, I mean, I would like, the first three are FIO benchmarks, so synthetic benchmarks, again, from the application, with the context switch, with the VFS, with all the other layers as well, to hardware persistency and back. The first benchmark is basically a single thread. So you can see you can get almost 500,000 file system accesses, 4 kilobyte, totally random. Everything's right. I mean, it's 420 times more that you can get with ZFS, for example. And at the same time, it's 480 times faster, each one of them. Okay, so really two to three orders of magnitude better than what you can have with current file systems, with current hardware as well.
I have a question about the ephemeral mode. Why would I use that at all? Why wouldn't I just use RAM? What's the advantage of having Plexistore in ephemeral mode?
So I'm hesitating if we should just skip the ephemeral to another, to one of the later slides.
Maybe we just.
But Justin,
because the
size. I got a large data set with a moderately small working set within it, and I can't afford that much DRAM, or I can't buy a server with 2 petabytes of DRAM.
But where's it coming? It's not in RAM now. So.
I'll try to answer that with when I cover the storage medias in the next next presentation.
All right.
I see the ephemeral stuff is hard to swallow, and this is storage field day, as you said. But the ephemeral stuff is a bit extending the traditional storage perception of things. So let's just move on and try to cover that later. Then for multi-threaded environment, I can, so this is really dependent on the CPU model. Okay, this is a single socket mid-range Haswell processor, so 2650 V3 Xeon processor. You can have more if you take something with more cores or higher frequency. Obviously, you can have less as well. It really depends on the CPU type that you choose. In this case, it's 5 million file operations per second, and because it's a pretty big pressure on the hardware itself, the latency goes up to 3 microseconds. Okay, and then one more thing, because we're dealing with a byte addressable media, NVDIMM or DRAM in that case, it's really easy to do tiny writes, which on block-based storage require read, modify, write type of access. And so the third one is just to emphasize that. So you can see basically more operations per second, and it's really native. As long as it's cache line multiplications of cache lines, it's really fast. The other three are basically SQL and no SQL examples. So this is from Spec SFS 2014. The operations, the number of transactions is basically fixed within the benchmark, so we're not presenting that. But you can see the latency improvement here by 15. I think Sharon also mentioned InnoDB or Postgres earlier, some results from that, like the 3x in throughput, and I think it was 6x in latency at the same time, improvement. And then MongoDB and Cassandra I'm not really going to talk too much about because I think Sharon presented very similar things. Just to show something here, I mean, this one shows, because it's with NVDIMM, shows that you can have last transaction safety with NoSQL, which is something that not many systems do. I mean, maybe SAP HANA, but you can see that the performance here is really poor, I mean, for traditional file systems. And this can actually be even further improved. Just a storage engine within the NoSQL middleware basically assumes that several things do not work as they do with SDM. So they do some redundant stuff like writing synchronously to the volatile data, and at the same time, maintaining a log. So that would be in our case. It makes perfect sense in traditional storage, but in our case, it's basically persisting the same data twice without any necessity. So that could still be accelerated. Okay.
And I need to ask about the difference between these three configurations. So earlier I asked, and I thought the answer that you said started sounding like you were talking about a cloud instance on the first two. But then a few minutes ago, I heard you say that this was a on-prem setup, right?
Yeah.
So this is all three on-prem, right?
Yeah, the example that Sharon gave earlier for Cassandra was measured on AWS.
Yeah.
These six are all on-prem.
Yeah, so set the AWS aside because that's blowing my brain. With the ZFS and XFS columns, is the ZFS and XFS on disk versus
on cloud speed SSD.
On SSD.
Yeah.
And you with this NVDIMM SSD combo thing.
Right.
Okay. And so I think, Justin, what you asked was, well, why don't you just do ZFS or XFS on NVDIMM? And the answer was, that costs a lot, right?
I have a slide on that.
So I do want to give an answer, a quick one. And I'm sure Amit can elaborate technically on why it behaves this way. But I want to clear the test scenario that we've done. In the case of ZFS and XFS, what we've done was we took a system of 64 gigabyte, okay? And what we've done is giving this 64 gigabyte to ZFS and XFS, okay? To Plexistor, we created a different system. We created a system that is 32 gigabyte of DRAM and 32 gigabyte for the primary tier, for the NVDIMM, okay? So Plexistor was actually using less memory. The system for Plexistor was actually having less DRAM. We took the same machine, exactly the 64 gigabyte, split it to two, 32 gigabyte for the memory, 32 gigabyte for the NVDIMM part, okay? The reason we did it is to give the ZFS a chance. To give the ZFS a chance to cache the data. This is, what happened is that actually ZFS got a 64 gigabyte for cache. And even with all that cache, it couldn't meet the performance, okay? That's the point that we're trying to make with that benchmark.
And how much NVDIMM would you be using?
32 gigabyte NVDIMM and 32 gigabyte DRAM. That's what Plexistor got. So in overall, it's exactly the same capacity. 64 in the case of Plexistor, 64 in the case of ZFS, and that's it. That's the difference. Okay, and to your question, adding more memory didn't help ZFS in any way. We actually gave it twice the amount of memory that Plexistor was using, and still it couldn't meet or achieve the same performance numbers.
Right, no, but what I was thinking is if I want to analyze some data, and I've got a certain data set that I need to analyze, I just load it in memory.
Sure, absolutely.
And analyze it.
That's absolutely fine.
So, in that case, there would be no need for me to have Plexistor.
You don't need Plexistor.
Yeah.
If the data set fits in memory, we've got nothing to do with it.
Right. But, so, okay. I was hoping that this would be, okay, the data set won't fit in memory. It will live on something else, like SSD.
Right.
Because it has to be on some sort of persistent media. And I want to analyze it, so I want to be able to load all of it in memory. I don't actually have all that memory. So I was hoping that if I put in Plexistore, that it will do essentially virtual memory paging management for me, that I can do something, so it will look like memory, and I can do byte addressable stuff to it, but not all of it is actually in RAM at the moment. Plexistore manages to get it down to there.
That's exactly how it works.
That's exactly what we do.
That's what you do.
Exactly that.
Wait.
Do I need to have NVDIMMs to do that?
If you need persistency, the answer is yes. If you don't need persistency, the answer is no.
Okay, so is it for the persistency, is it the specific kind of, I need to protect it from particular failure? What failure modes are you protecting against for the persistency? Because
immediate power failure.
Immediate power failure. Okay.
So this is actually in the public beta, I think you call it, right? That's out there that everyone can test for themselves. What I'm about to show you is a roadmap feature. It's not in production yet. I mean, it's in R&D. It's not released yet. That's what I mean. So let's start with the context maybe first. So this exactly goes back to the HA functionality, mirroring between different nodes. The way we see it is basically you have n application servers. Each one, SDM runs on each one of them, serves the application itself, and then we dedicate several boxes. Could be the same boxes, could be other boxes that are basically the persistent memory and flash. These hybrid bricks. Okay, and these bricks basically they're on the hardware side. It's more economical to tweak them a bit different than actually dedicating another application's resources on another application server. But that's up to the user basically. And
it's a brick?
Yeah.
Okay.
And showing the performance numbers. Okay, let's start with the black line over there. That's actually random 4K writes. And the latency for that, we've seen the number before, but we've seen it for the maximum value. It starts, for 100K operations per second, it's basically 1 microsecond. As the load continues to grow, latency goes up. And at some point, the hardware itself, the interconnect within the socket itself, and the bottlenecks on the L2 caches and their connectivity basically goes up, and the latency goes up as well. So it reaches 3 and 4 microseconds as well. But that's obviously for 3 million operations per second per a single socket, which besides FIO, I'm not familiar with any application that actually does that. Now going to mirroring, we basically have two options, right? One is synchronous mirroring, and the other one is asynchronous mirroring. Now, on a local node, everything is done synchronously. I mean, the developer, the programmer can basically write whatever software they want. Could be asynchronous, could be direct I/O, could be synchronous. Everything will be direct I/O and synchronous to the device itself, to the memory itself. Okay. When we're talking about mirroring, that doesn't make a lot of sense because there is a trade-off between network and between latency and the persistency on the second node. So the blue line, the light blue over here, would be the latency for an asynchronous mirroring, right? So that's basically 1 microsecond penalty on the right for having another copy, which is almost as persistent, but the emphasis is in almost. We're not waiting for an acknowledgement from the other node. We're sending the data at the same moment, but we're not waiting for the acknowledgement that he has arrived to the other side. And then the synchronous path is actually what I just said. We are waiting for the acknowledgement, and that carries another penalty. So you see it starts at 4 microseconds for a fully synchronous copy, again, from the application itself, including all the context switches and everything else within that. And then it grows to 5.5 or something like that, including one switch in this case in the way. Okay. We are providing that API for building, for the communication between the PM brick and the application server itself. It's basically pretty simple. I mean, it's RDMA based, and there are 2 out of the 4 are basically tiering hints. So the PM brick itself could aggressively tear down the data. So we actually provide the hints from the application server to the PM brick so they can free up the expensive PM resources and tear down the data to hard drives or some cheap SSD in that sense.
Before you continue, just about the PM brick, persistent memory brick, that's the term. This is not something that we've invented. That's a term that exists in the industry. You can find companies trying to build those PM bricks. It can be implemented over NVMe, over fabric appliances. PM brick, the concept was to take NVDIM of some kind. It doesn't really matter if it's physically implemented by 3D Crosspoint or other technologies. Make it a shared resource where all the applications or all the servers in your enterprise can use it, allocate space there and use it. we are riding on the concept of pre and brick and using it as a target for HA. Okay?